Warning: this reaction is dangerous. It uses both nitric and sulfuric acids. Both can burn and blind you. It uses benzene, a known carcinogen. It produces nitrobenzene, a suspected carcinogen that can be absorbed through your skin and raise your heart rate to a dangerous level. The reaction itself is highly exothermic and can get out of hand if not watched carefully. This reaction should only be performed in a fume hood, as it also gives off toxic gases. Be sure to wear proper safety equipment and limit your exposure. Hello everyone. In this video we'll be making nitrobenzene, a useful starting point for chemical synthesis that we'll be using in a future video. To begin, you'll need an ice bath set on top of a magnetic stirrer with a beaker in the middle. In the beaker, place a stir bar and 80 milliliters of concentrated sulfuric acid. Let it set for some time to allow the acid to get cold. In the graduated cylinder is 70 milliliters of concentrated nitric acid. Once the sulfuric acid is cold, begin stirring and very slowly start adding the nitric acid. The nitric acid is the stronger acid of the two and will deprotonate the sulfuric acid, generating the nitronium ion in situ. The nitronium ion will act as our electrophile in our reaction. Once all the acids are mixed and have cooled down, you can begin to add the benzene. Place 60 milliliters of benzene in a set funnel and set it up to begin dripping the benzene into the acid. Also add a thermometer to keep track of the temp. We do not want the temperature to exceed 50 degrees C, or we will start to get side reactions that we do not want. I set my drip rate so that the temperature did not go over 40 degrees C. Setting it up like this works well, as you can do other things in the lab while keeping a very close eye on it. The complete addition of the benzene took about an hour. So if you're curious as to what's going on, here it is in a nutshell. As stated earlier, the nitronium ion is our electrophile, and it will attack the aromatic substrate of the benzene molecule to give the resident stabilized rhenium ion. The ion is then deprotonated by the bisulfite ion formed earlier by the deprotonation of sulfuric acid, thus forming nitrobenzene. After all the benzene is added, remove the beaker from the ice bath and stir for about 30 minutes to allow it to come to room temperature. Then stop stirring and let it sit. It should separate into two layers. The top is our nitrobenzene and the bottom is mixed acids. Pour the contents of the beaker into a set funnel and let it set until the two layers reform. Then remove the bottom layer and discard. To the set funnel, add 40 milliliters of cold water and shake, remembering to vent. You will again get two layers. The nitrobenzene will turn a yellow cream color and is now the bottom layer. Remove it and save, and then remove the aqueous layer and discard. Replace the nitrobenzene in the set funnel and add more water. Repeat the washing at least 3 to 4 more times to remove the acid. Now we need to distill our product to remove most of the water and any side products or contaminants. Pour the nitrobenzene in a boiling flask and set up for a simple distillation. The nitrobenzene comes over at around 207 to 211 degrees Celsius, so be sure that your setup can reach and handle the high temp. Also be aware that any condensed water that falls from the thermometer or the sides instantly vaporizes on contact with the oil. If your setup is not clamped tight, this sudden influx of steam could blow it apart, so please be careful. So here's what I got after distillation. Nitrobenzene is clear to pale yellow, and you can see here that it's still cloudy. This is from water contamination. To remove it, add 3 to 5 grams of calcium chloride. As you can see, the calcium chloride removes all the turbidity, giving us the clear yellow of nitrobenzene. All we need to do now is decant the solution into a bottle for storage. My yield was about 15 milliliters, or 83%, which will give me more than enough for my future video on aniline. Thanks for watching.